From phonetic analysis to electroacoustic composition. When we think of electroacoustic creation today, we often think of real-time interaction, instant synthesis, live coding, or, more recently, artificial intelligence models that operate as a kind of black box. We send sound into a system, and something comes back, transformed, generated, reimagined. But what happens when we want to slow down? What happens when, instead of asking the computer to respond immediately, we ask it to reveal something about the sound itself? What happens when we want to break sound down into its components and edit its internal acoustic structure, almost as we would edit notes in a score? Today, I will present Praat AudioTools, a project of mine that takes the scientific tool for speech analysis, Praat, and adapts it to the needs of contemporary research and composition. I will demonstrate how phonetic analysis objects, such as frequency curves, intensity contours, formants, spectral envelopes, and temporal structures, can become the basis for creating new sound worlds. The central idea is simple. What if we could use sound analysis not just to understand sound, but to compose with it? Praat AudioTools was created in response to this question. It is an open-source library of more than 400 scripts that transforms the long-standing phonetic analysis software Praat into an object-oriented laboratory for electroacoustic composition. Praat is widely used in linguistics, phonetics, and speech research. It is a precise, stable, and highly developed environment for measuring and representing sound. Yet its potential as a compositional environment has been relatively underexplored. The library I built proposes a different workflow. In this workflow, phonetic analysis objects function as parametric musical scores. A pitch curve is not only a measurement of frequency over time, it can become a melodic contour. A formant structure is not only evidence of vocal resonance, it can become a spectral model. An intensity curve is not only a representation of loudness, it can become a dynamic envelope. These objects sit between the sound file and the score. They are neither raw audio nor traditional notation. They are acoustic traces that can be edited, transformed, recombined, and resynthesized. This is where the title of the lecture comes from phonetic analysis to electroacoustic composition. The movement is not simply from science to art, or from analysis to synthesis. Rather, it is a circular movement. Analysis, editing, rendering, listening, and then analysis again. Unlike real-time performance environments, such as Max/MSP or Super Collider, which are designed for low-latency interaction, Praat AudioTools favors what I call the deep time of studio composition. The composer is not required to react instantly. Instead, the composer can inspect a sound slowly, intervene inside its structure, and listen again. This places the work within a studio tradition, where the act of composition is based on repeated listening, comparison, and refinement.
Qu'est-ce que tu regardes? Toi, je te regarde, tu regardes quoi? Ton image, ton corps tout entier, t'es la tête, de la tête aux pieds, alors tu me déshabilles, oui, non, ah bon, tu me rassures, je te rassure, de toute façon, tu m'as jamais vu toute nue, alors je me déshabille, oui, mais ne regarde pas, non, qu'est-ce que tu regardes? Je regarde toi, ton image, ton corps tout entier, t'es la tête, de la tête aux pieds, alors tu me déshabilles, oui, non, ah bon, tu me rassures, je te rassure, de toute façon, tu m'as jamais vu toute nue, non, alors je me déshabille, oui, mais ne regarde pas, non.
At the same time, the project also connects with spectromorphological thinking. It guides the composer to listen not only to pitch, rhythm, or harmony, but to internal acoustic behavior, movement, density, resonance, spectral color, transition, noise, and contour. The sound is understood as a dynamic object whose parameters can be exposed and reshaped. The methodological heart of Praat AudioTools is what I call an in-between editing approach. In many computational workflows, especially in Python or in MIR-based systems, the process is often linear. First, we analyze the sound. Then we write code. Then we render a result. The composer usually gets involved before the analysis or after the rendering, but not always inside the analysis object itself. Praat AudioTools changes this relationship. In this approach, the composer steps directly into the analysis phase, reshaping the traditional three-stage workflow. First, the system extracts an acoustic object from a sound file. For example, it may extract a pitch tier representing the intonation of a cello phrase, or a formant object representing the resonant behavior of a spoken vowel, or an intensity tier representing the dynamic energy of a sound. Second, the composer edits this object. Sometimes this is done graphically. Sometimes it is done through a script or a user interface. The important point is that the composer is not editing the waveform directly. The composer is editing a parametric profile of acoustic behavior. Third, the edited object is fed back into a synthesis or transformation process. The object returns to the sonic world. What was once a measurement becomes a compositional instruction. This approach turns precise phonetic measurement into compositional raw material. For example, imagine that we analyze the pitch contour of a spoken sentence. In a linguistic context, this curve might be used to study intonation, accent, or prosody. But in Praat AudioTools, the same curve can become a melodic model. We can stretch, invert, smooth, amplify, quantize, or transfer it onto another sound source. Let's listen to an example where the voice of composer Josef Tal becomes a sequence, drawn from a corpus of 150 short phrases I played on the flute. Example 1. Spoken phrase.
נתבקשתי לשוחח עמכם על הנושא המוזיקה במאה ה-20.
Example 2. Instrumental texture. The combined result.
נתבקשתי לשוחח עמכם על הנושא המוזיקה במאה ה-20.
Next, imagine that we extract formants from a vocal sound. In speech analysis, formants help us understand vowel identity and vocal tract resonance. In composition, however, they can become spectral filters. They can be imposed on noise, on instrumental sound, or on synthetic material. The vocal body becomes a resonant architecture that can color other sounds. This is important because the library does not treat analysis as a neutral or passive stage. Analysis is already a creative act. The choice of what to extract, what to preserve, what to amplify, and what to discard becomes part of the compositional process. Example 3. Spectral filters. The library currently contains 13 functional categories tailored to compositional and research needs, ranging from artificial intelligence and deep learning, synthetic generation, and deep sound analysis to filtering, spatial processing, and acoustic simulation. This division grew organically out of my own compositional practice. It was not designed only according to software engineering logic, but according to the needs that emerged while composing. In other words, the architecture of the system favors compositional intent over technical implementation. The composer does not need to begin by asking which algorithm is being used. Instead, the composer begins with a sonic question. How can I reshape the color of this sound? How can I make one sound taking over the spectral behavior of another? How can I create a transition between two timbral identities? The same applies to the spatial and surround category. Here again, the focus is not only on implementation, but on compositional navigation. How does sound move? How does it occupy space? How can spatial motion become a structural parameter? The categories are meant to help the composer move through the system according to musical and research questions: analysis, transformation, synthesis, spatialization, filtering, segmentation, simulation, and machine-assisted parameter generation. One of the key aspects of Praat AudioTools is that it keeps the process visible. This is especially important today when many contemporary synthesis tools are based on machine learning. Systems such as RAVE or DDSP can produce fascinating results, but they often operate in a way that is difficult to inspect. The composer feeds sound into a model and receives sound back, but the inner transformation may remain inaccessible. Praat AudioTools takes a different position. It does not reject artificial intelligence. On the contrary, it includes tools that can use machine learning for analysis, classification, sequencing, or parameter generation. But it argues for what I call transparent neural processing. The point is not only to generate a sound, but to understand the path by which the sound was generated. Machine learning can help suggest, classify, interpolate, or structure material, but the final synthesis process remains connected to adjustable objects and intuitive parameters. This preserves the epistemic agency of the creator. By epistemic agency, I mean the ability to know what has changed, how it has changed, and why it has changed. The composer is not only choosing between outputs, the composer is working with the internal conditions of the transformation. This is also where the project connects to research creation. Praat AudioTools is not only a toolbox for producing pieces, it is also a way of documenting compositional thinking. The scripts, objects, parameters, and intermediate analysis files form what we might call a process archive. They show how a sound was analyzed, how it was transformed, and how the final result emerged.
Qu'est-ce que tu regardes toi? Je te regarde, tu regardes quoi? Ton image, ton compte entier, t'es la tête, de la tête aux pieds, alors tu me déshabilles. Oui, non, ah bon, tu me rassures, je te rassure, de toute façon, tu m'as jamais vu toute nue, alors je me déshabille. Oui, mais ne regarde pas, non, qu'est-ce que tu regardes? Je regarde toi, ton image, ton compte entier, t'es la tête, de la tête aux pieds, alors tu me déshabilles. Oui, non, ah bon, tu me rassures, je te rassure, de toute façon, tu m'as jamais vu toute nue, non, alors je me déshabille. Oui, mais ne regarde pas, non.
In traditional composition, the score often stands beside the work as a document of musical thought. In electroacoustic music, this relationship is more complicated. The final work may exist only as a sound file, while the process behind it disappears into software sessions, plugins, presets, or undocumented transformations. Praat AudioTools proposes another model. The process archive becomes part of the research contribution. The analysis objects and scripts can stand beside the finished sound work as evidence of method, decision, and transformation. This also has practical implications. Praat is a software environment that has been continuously maintained for decades. It is stable, cross-platform, and widely used in scientific communities. This gives Praat AudioTools a degree of a long life and reproducibility that is often difficult to achieve with commercial plugins or rapidly changing creative software ecosystems. For artistic research, this matters. If we want electroacoustic composition to be understood not only as a finished artwork, but also as a form of knowledge production, then we need methods that can be shared, repeated, inspected, and criticized. We need tools that allow others to understand not only the result, but the pathway toward the result. Let me now give a concrete example of this workflow.